Okay, good morning. Welcome to
FunMath number 167.
FunMath number 167. We're still in section 9.4 of Art of Problem Solving's Algebra book, and we're learning about graphing inequalities. And so what region does this inequality describe? So we're just going to take a shot. It's very similar to the video we did yesterday, but that's okay. All right, are you ready?
Yeah.
Graph the region described by x plus 2y is greater than or equal to 4. Okay, so how do you want to approach this?
Take the equation. We know how to solve equations like x plus 2y equals 4.
Okay.
We solve this by, it's 2y is minus x plus 4.
Okay.
And y is minus x over 2 plus 2.
Okay, so that's a line, y equals minus x over 2 plus 2. And what is this form of the line called?
Slope-intercept form.
It's the slope-intercept form. Okay, so what's the slope of this line?
Slope is minus 1/2.
Okay, and what's the y-intercept?
It's 2.
Okay.
So it crosses the y-axis at 2, 0. Or the x-axis. 0, 2.
It crosses the y-axis when x equals 0,
yeah.
Y equals 2. So I'm just going to say that's here. I'm not going to label. Okay, so now I'm going to give you 3 possibilities for what this line might look like, so we don't just graph some points. Does it look like this? Does it look like that? Or does it look like that? Which one? Those probably aren't showing up on camera too well. Which line of those 3 is it? So this,
I think the third line.
This. Okay, why do you think it's that?
Well, the first one looks pretty steep.
Pretty steep. First one's pretty steep.
The second one still looks a bit steep.
Okay.
The third one's pretty shallow.
Third one's pretty shallow. Okay, so let's just say the line looks like kind of that does look like a slope of about minus 1/2. And let's just check. This was x equals 0, y equals 2. What is it when y equals 0? Where does it cross the x-axis? So if this was the point 0, 2, this would be the point what? Where does it cross the y-axis? Something
0.
comes 0. Yeah. What is x when y equals 0?
It's minus something. It's minus 4 over 2 plus 2.
Okay, so what is x?
Minus, it's 4.
4. Okay, does that look like it could be
Yeah.
4 if this is 2? Could that be 4? Okay, so it looks like we got it right. So now we're doing greater than or equal to 4. So we have to decide if the region is above this line or below this line.
Let's use our 1,000,000 points.
Okay, let's use our 1,000,000 points.
See if x is 1,000,000.
If x is 1,000,000, now you got to go back to the inequality here.
Then it's greater than 4.
If x is 1,000,000 and y equals 0, so we're on the x-axis.
So and when
We have 1,000,000 is greater than 4. Okay.
and when y is 1,000,000,
And x is 0.
It's greater than.
Okay, so what we do is we check large points on the axis. Okay, now what if we check down here when x is 0 and y is minus 1,000,000? Are we greater than or equal to 4?
No.
No. Okay, so what we're going to be doing is shading up here.
Let's not shade it.
Yeah, let's not shade it, because if I shade the whole thing in black and then when I go to erase, the whole board turns black, right? Okay, so we would be shading up, and because this is greater than or equal to, it actually does include this line. The line is where it equals 4. Okay, but one thing we talked about in this section is just notation. What if I had made this strictly greater than 4? What do we do to indicate that we don't include the line?
We make the line a dashed line.
Make the line a dashed line. That's just the mathematics. That's what people do, because when you do it on a number line, you leave an open circle to say you don't include the point, but you can't make an open circle with the line. So when it's strictly greater, then we make a dashed line instead. And it's the same idea. We would just shade up. So we have the region above this line. Now, is it always true that greater than is above the line?
Not always.
Not always. So we do have to just check. Just check some points to see where we are. And it's easy to check the axis.
Yep.
Okay? Good job. Good job, sweetie.